All right, before we start this one, real quick, on your paper, it probably says right here where mine says AB equals 9, yours probably says AB equals 0. So that should be changed so that says AB equals 9. All right, so assuming now that that says AB equals 9, it says triangles ABC and DEF are drawn to the right. Which of these statements is true? So what we're going to look at here is we're going to say, well, let's figure this out. So AB equals 9, fine. BC is 15, DE is 6, EF is 10, and B equals E. Well, this looks like an SAS situation. I wonder if that's SAS similarity. Well, if it's SAS similarity, then 9 over 6 should equal 15 over 10, and those both reduce down to 3 halves. So the sides are proportional, the angles are equal. These triangles are similar by SAS similarity. And that is what we talked about in the last lesson. Now the question says, which statement is true? Does that mean CAB, this guy right here, is equal to DEF? DEF, well no, DEF is that guy, that can't be true. Is ABC similar to DEF? Well, we said the whole things are similar. Let's check out our corresponding parts. ABC goes from short side to the known angle to the long side. DEF goes from short side to the known angle to the long side. Yep, there it is. That's it. I don't even care about the other ones. All right, given that these two things are similar, find the missing length. So I'm going to call that X, and I'm going to call this Y. And we're going to set up some proportions here. So if I look at this one, ABC is similar to A prime, B prime, C prime. So just the way it's drawn. So 4 and 12 go together, and X and 6 go together. They're corresponding. So when I cross multiply this, I have 24 equals 12X. Divide by 12, and you get X equals 2. If I then want to solve for Y, I can still start with 4 to 12. And then I have 5 to y. 4y equals 5 times 12, which is 60. Divide by 4. Y is 15. Easy peasy. Cruising right along. In the diagram below, these triangles are similar, though. This is new. These triangles are similar. AC is 12. Okay, thank you. DC is 7. Okay, thanks for that. And DE is 5. And the perimeter of this whole thing is 30, they want the perimeter of this whole thing. All right, well, one of the things that we've talked about a little bit before is that the ratio of the side lengths is equal to the ratio of the perimeters. So my side lengths have a ratio of 12 to 7, because this is the side that I know that's AC, and AC would correspond with DC, which is right here, and that's 7. 12 to 7 is not only the ratio of the side lengths, but it's also the ratio of the perimeters. That is the perimeter of ABC when compared to the perimeter of DEF. So 12 to 7 equals 30 to x. So 12x equals 210. Divide by 12. And I will get, I'm just doing it off to the side in a calculator, boop, 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 17 and a half. Actually, I lied. I didn't use a calculator. I did this before. I'm copying off my answer key. Ha ha ha. All right, there you go. There's perimeter. Ta-da, done. Now, those are kind of reviews of things we've done before. This is slightly different, but not too bad. We have shadow problems. Shadow problems always make proportions because you have nested triangles that are similar. So you just have to figure out how to set up the proportion and make sure that corresponding pieces go together. So when you have shadow problems, which are very common, you have to remember it's basically object to shadow equals object to shadow, or object 1 to object 2 equals shadow 1 to shadow 2. So in this one right here, I have a height of 35 for the flagpole and a 60-meter shadow, then a height of the building I don't know and a 170-meter shadow. Okay? So, if I look at something like this, Marquis realizes when he looks up from the ground 60 meters away, I know it isn't a shadow, but it's the same idea, that he has everything that lines up right here. I can just set up a proportion and basically say, let's pretend this is the shadow of the flagpole, that's the shadow of the building, how tall is the building? So the flag to the distance from the flag out is 35 to 60, and the building to its horizontal distance is h to 170. And then you just cross multiply. So I cross multiply that. I get in my calculator 5950 equals 60h. Divide by 60, and you get h equals 99.16. It says, how tall is the building? Are the triangles similar? Explain. Well, let's talk about similarity. Things are similar if I can show side similarity, side angle side similarity, or find two angles that are the same. Well, let's see. If this is a building and that's a flagpole, they should make 90-degree angles with the ground. There's one congruent angle. Then this angle up here is the same angle for both this triangle and that one. So I have angle-angle similarity. So yes, they are similar. Here's a shadow problem. Same thing. Flagpole casts a shadow 16.6 meters long. So here's a flagpole. Here's a 16.6 meter shadow. Tim stands 12.45 meters from the base. So Tim is standing right here. And Tim's shadow ends where the flagpole shadow ends. If Tim is 1.65 meters tall, determine the height of the flagpole. All right, so object to shadow equals object to shadow. So the object being the flagpole has a shadow of 16.6 meters. Tim, being 1.65 meters tall has a shadow that's here. Well, that's really just 16.6 minus 12.45. It's the leftover, right? And boop, boop, boop. When I do this off to the side, I get 4.15. So that's really going to be Tim's shadow. And then I cross multiply, boop, 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 in my calculator off to the side. 27.39 equals 4.15x. Divide by 4 and 1/1500ths, and I get x equals 6.6. So there you go. All right, and then last but not least on these, we're just going to set up some ratio problems that actually don't really have to do with ratios. This should be some review because I'm sure you've seen things like this before. The ratio of two supplementary angles is 4 to 5. Supplementary, what's that mean? I know. Who knows that? Oh, it was me. I know that. Supplementary means they add up to 180. So if I have two supplementary angles in a ratio of 4 to 5, that means 4x plus 5x equals 180. And then you solve the resulting equation. So 9x equals 180. Divide by 9. X equals 20. Then it says find the measures of each angle. So the first angle was 4x. When x equals 20, that's 80 degrees. And then 5x is going to be 100 degrees. Ta-da! The ratio of two complementary angles. What's complementary? Oh yeah, there's that trick Mrs. Vibber showed us. A C becomes a 9 for 90. Complementary means they add up to 90. So I have 2x and I have 3x and they add up to 90. Huzzah! 5x equals 90. Divide by 5. X equals, what do you got there, 18? Find the measures of each angle. So 2 times 18 is 36, and 3 times 18 is 54. 2 more and I'm done. 3-foot stick is broken into 2 pieces. The pieces are in a ratio of 5 to 7. How long are they? 5x and 7x add up to the whole 3-foot long stick. 12x equals 3. Divide by 12. And I get x equals 0.25. Each of the pieces is 0.25 feet or 3 inches long. Wait a minute, Mrs. Vibber, no, that doesn't mean that all the pieces are 0.25. That's the multiplier. You're right. Try to resist the urge to just say, I found an x, let's keep going. No. How big are the pieces? 5 times 0.25 is 1.25 feet for the first piece, And 7 times 0.25 is 1.75 feet for the second piece. And last but not least is the largest angle acute obtuse or right in a triangle that has angles in the measure of 2x to 3x to 4x. Mrs. Paper, it doesn't say 4. That's okay. If you see an extended ratio, that always means that those guys get an x. So 2x, 3x, 4x adds to 180 because it's in a triangle. 9x is 180. Divide by 9, x is 20. It says is the largest angle acute, obtuse, or right. So the largest angle would be 4 times 20, which is 80. That is acute. All right, we are just over 10 minutes. Let's do a joke, and then you will finish up the problem set in class. So the joke today is, where does a snowman keep his money? In a snowbank. I know, that one was terrible, so I'm going to give you another one. Why did the banker break up with his girlfriend? Because he was just losing interest. That one's pretty funny. Alrighty then, good luck with proportions. Toodles.